Chapter 6, Section 5, Day 3 is all about square root equations that are considerably harder than the others, most often having some kind of exponential fraction instead of actual radicals. So just a quick reminder that anytime you solve equations that have radicals or equivalent fractional exponents, you isolate first, you raise second, solve third, check fourth. Each of those steps are as important as the others. So taking a look at the very first one, that fractional exponent is actually a radical. So the first thing you want to do is isolate that. I'll do so by dividing both sides by 3. So you're left with x plus 1 to the 2/3 on the left and a 4 on the right. 12 divided by 3 is 4. To get rid of something to the 2/3 power, you can raise it to the 3/2 power. So we're going to raise both sides to the 3/2. Because what ends up happening is the 2/3 times 3/2 is a power to a power. And anytime you have a power to a power, you multiply, you get 1. So the whole left-hand side cancels to just x plus 1. The right-hand side is a problem, though. Focus on the fact that the exponent we're raising it to is a 3/2. The denominator is even. That's an even indexed root. So when you do 4 to the 3/2, you get a plus or a minus. You get both the primary and its opposite root. And so 4 to the 3/2 means the square root of 4 cubed, which is the same as 8. So I get a plus or minus 8. That's two separate equations. I'll do this one first. That's x plus 1 equals 8, and that's x plus 1 equals negative 8. Solve them both. Solve one at a time, though. If you solve the one on the left by subtracting 1, you get 7. If you solve the one on the right by subtracting 1, you get negative 9. You still have to check them both. So the first one I'm going to check is the positive 7. That means 3 times 7 plus 1, plus 1, to the 2/3 should equal 12. 7 plus 1 is 8, and 8 to the 2/3 is 4. So we get 3 times 4 equals 12. Use your calculator if you need to, but that one does check. Check the negative 9 as well. 3 times negative 9 plus 1 to the 2/3 should equal 12. Negative 9 plus 1 is negative 8, and negative 8 to the 2/3 is actually a positive 4 as well. Again, check your calculator if you need to, but that one checks too. So we get both are good solutions. Number 2, isolate that radical first. In order to do so, I'm going to subtract 1. I get 3 times the 5th root of that really gross x plus 1 quantity cubed equals 24, because 25 minus 1 is 24. Then divide both sides by 3. You get the 5th root of x plus 1 cubed equals 8. 24 divided by 3 is 8. I'm going to take a second and rewrite this left-hand side. It'll make things a lot easier. That's the same as x plus 1 to the 3/5. Remember the bow tie thing. The bottom number is outside, the top number is inside. And the reason I do that is because at this point, I can just raise both sides to the 5/3 power. Taking the 5/3 power really means I'm cube rooting, so there's no plus or minus. On the left, I get x plus 1. On the right, 8 to the 5/3, if you need to use the calculator, is 32. Cube root of 8 is 2, to the 5th power is 32. And if I subtract 1, I get x equals 31. We're going to check that. So 3 times the 5th root of 31 plus 1 squared, or not squared, sorry, cubed, plus 1 should equal 25. You can, if you want, take this whole thing and type it into the calculator. You should end up with 8, though. So what you really have is 3 times 8 plus 1 is 25. So 24, 3 times 8 is 24, plus 1 is 25. And that one does, in fact, check. Always check your solutions. All right, number 3. Number 3 is a little trickier because it has 2 different radicals. So the first thing I want to do is recopy it. X plus 5 to the 1/2 equals 5 minus 2x to the 1/4. The 1/2 and 1/4 are tricky. Most students would see the 1/2 and try to square both sides. So just take a second. I'm going to erase this, so don't write it down. But if I take this side and square it, what you've got is a 1/4 to the 2nd power which is the same as 1/2. That's a square root. And so I don't really take care of the problem. I still have an issue going on. So instead of raising it to the second power, try raising it to the fourth power. So on this side, we're going to raise it to the fourth power. This one's a little different because it's this side that ends up prettying up for us. 1/4 times 4 is 1. But over here, 1/2 times 4 is 2. And so what ends up happening is on the left-hand side, we get x plus 5 squared because of the 1/2 times 4. But on the right, we get the 5 minus 2x. All of that disappears. You're forced to FOIL on the left, x plus 5 times x plus 5. And recopy equals 5 minus 2x. If you FOIL and combine like terms on the left, you get x squared plus 10x plus 25. And then recopy equals 5 minus 2x. I'm going to get that equal to 0. Anytime you have a quadratic and you want to solve, set it equal to 0. So I'll subtract 5 and add 2x. I end up with x squared plus 12x plus 20 equals 0. At this very moment, hope that you can find two numbers that multiply to 20 and add to 12, and you can. They happen to be 2 and 10, which means that my solutions are -2 and -10. You do have to check them both, so I'll check the -2 first. So that means -2 plus 5 to the 1/2 should be the same as 5 minus 2 times -2 to the 1/4. Okay, on the left, -2 plus 5 is 3. On the right, I end up with a 5 plus 4, which is 9. And I know you might not be able to see it, but if you use the calculator, they are equivalent, so -2 checks. I need to check -10. -10 plus 5 to the 1/2 should be the same as 5 minus 2 times -10 to the 1/4. On the left, -10 plus 5 is -5. And on the right, 5 plus 20 is 25 to the 1/4. Take a second and look at that. -5 to the 1/2 is a no solution. You can't take the square root of a negative answer. And so this one is extraneous, only -2 checks. In the you try it, both of those happen to work. Don't forget the plus or minus 8, because what ends up happening right here is you end up taking an even root, which is always plus or minus.